Guess what time it is? It's time to do some proofs with the base angles theorem. Copy it down, pause when you're ready to go. Let's hit this hard. Let's go. All right, so we've got triangle ABC is isosceles and AC is the base. What does that tell us? Well, that would tell us that the legs are congruent, right? So that means that my legs, which are AB and BC, are going to be congruent by the definition of an isosceles triangle. I'm also given in this proof that angle ADB, right here, is congruent to angle CDB, right there. Okay. Now we want to prove that these two triangles, ADB and CDB, are congruent. Remember our ways to prove congruence, okay? So we have side, 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 angle, side, angle, sorry, angle, side, angle, and angle, side, and HL. HL is only for a right triangle. You can suspect here that you do have those right angles making a right triangle, but we're not going in that direction. That's going to take us a couple more steps, so we're going to scratch off HL. If I look at what I have here, I have an angle and a side already. An angle and a side. So I'm going to cross off side, side, side because that doesn't involve any angles. Now, look at our options, okay? Side, angle, side. Can I get another side congruent? Yeah, I actually could. DB. Now, if you were going to say the reflexive property with DB or BD being congruent to itself, you would get angle, side, side. Ooh, angle, side, side. No. If you use angle, side, side, and it's not a right triangle to say HL, you are what you write. Don't write that. So I'm gonna, so for side, angle, side, the angle would have to be the included angle. And here, there's no way that I could get an included angle. So side, angle, side is going to be scratched off our list. Angle, side, angle, meaning that the side's the included part. Well, here's my sides being the included parts. I don't know how I could get this angle and this angle, maybe that angle, we could get congruent to make the side included. So that's going to be scratched off our list. So then we're left with angle, angle, side. Now, can I get angle, angle, side? Absolutely. We just talked about that base angles theorem, right? The base angles theorem says that if two sides of a triangle are congruent, the sides opposite, or I'm sorry, the angles opposite those sides are congruent. So if I look at the angles opposite those legs, right here, that gets me this angle and this angle. Those angles are now congruent by the base angles theorem. Okay, so angle BAD is congruent to angle BCD by the base angles theorem. Now, if I were just to clean up my sketch a little bit, get rid of those arrows that I drew. Okay, let's just have our markings on our sketch. We knew this because of the isosceles. We were given these angles are congruent, and now we just proved by the base angles theorem those angles are congruent. So focusing on the smaller triangles, look at what we have. We have angle, angle, side. Angle, angle, side, which is what we suspected we would need to use. So we are finished with this proof. Triangle ADB is congruent to triangle CDB by the angle, angle, side theorem. I'm sorry, I should actually write that in there. This is the theorem. Remember, there's only two theorems. The other ones are postulates. All right, let's do one more example with proofs. So copy this one down, pause, and when you're ready to go, we'll complete it together. All right, so here I have marked all my given information on the sketch, and I put those little dots there. Doesn't that look like a mean face? Like, okay. I put these dots there to show us where we have to, what we have to prove. Okay, now this one's actually a little harder because the triangles that we're going to be looking at are overlapping. So let's just focus on the givens. If I know that angle BAC is congruent to angle BCA, okay, there's my bottom angles marked. By the converse of the base angles theorem, I would then know that the sides opposite those angles are congruent. So my second step is going to be that segment BA is congruent to segment BC. And this is the converse of the base angles. Where'd my pen go? Oop. Why did it do that? Theorem. Alright, so again, we're going to look really for some triangles. If we could get triangles congruent, then we could probably get some corresponding parts congruent. Do you see any triangles that include angle BDC and angle BEA? I see two right here. So let me bring up my highlighter. This triangle here, triangle BEA. Now watch what I'm going to do. I'm going to highlight it and separate it out. Okay, let's move that triangle over here. And then let's do a green one, triangle BDC. Okay, so I'm going to highlight that and I'm going to bring it outside. Move this guy over here. Bring it outside of the original sketch. Okay, by doing that, we can kind of see a little bit better what's happening. So we have, this was angle B, this is angle A and E. And here this was B, D, and C. Okay, so if I just mark what I had already marked, which is BA is congruent to BC by the converse of the base angles theorem, right? We also know that BE is congruent to BD, that was given, right? If I want to show these triangles congruent, do you see any, and here's the angles we want to prove congruent. Let me mark those with my little dots, right? Do you see anything else that we could possibly know to prove these triangles congruent? I already have two sides. So if I already have two sides, I could go side, side angle, side. And that's really it. That's our only options. Do I know anything about AE and DC? No. Side's off the list. Can I get an included angle between those two sides? Yes, I can. Angle B is congruent to itself, right? So that's the reflexive property. I'm going to say angle DBE is congruent to angle DBE. And technically this is the only angle that occurs at that vertex, so you could actually call it angle B, but I'm just going to use all three letters. So this is the reflexive property. Now we know that the triangles are congruent. So triangle BAE is congruent to triangle BCD. And this is by side angle side. And if the triangles are congruent, we know that all corresponding parts are congruent. And the corresponding parts that we really want to focus on is angle BEA and angle BDC. So we are finished with this proof. So angle BDC is congruent to angle BEA. And this is CPCTC. All right? Adios.